Welcome to the CADclass Podcast, where makers are made. I'm Josh.
I'm Jake.
It's nice to be with you all live once again.
We've been with filming a new set. Finally,
we've
finally changing it up a little bit.
Yeah.
Oh my god.
Yeah.
I am. You guys have no idea how excited I am to actually make this look a little bit more cinematographic. Yeah, we'll call it that.
Cinematographic.
That's a good one. Yeah.
Hey, look at that. Printed by John. Loves your setup. So good morning. Printed by John.
Thanks very much.
Good morning.
Yeah. I've we got to change it a couple weeks ago, and I've been itching to film something. And annoyingly, all the videos that we film for the YouTube channel, they take like a month to do on and off. They take ages and ages. So I'm like, I just want to film some shorts. I just want to film like a crappy, quick little 5-minute video. And it's going to take a couple days, and that's it. And I just want to make something. Because unfortunately, what happens with getting, lenses and cameras and all that good stuff is like, oh yeah, you always want to have your background really, really fuzzy and you really, really sharp. And it's like, oh, great, awesome. And then as you're setting up, you're like, but I've got all this stuff that I really enjoy that I want to show off. It's like, nope, nobody can see anything. So I'm like, okay, I'm gonna do some funky camera angles. But yeah, it'll be a nice fresh look for all the videos and for all of our courses as well. So very happy about that. But dude, we've got lots and lots and lots of stuff to show off this week. Sorry, we've been gone for a couple of weeks. We've been continuing on with our interview series. That's actually a ton of fun to do. But we're going to be talking about a couple more of the projects and books. I'm going to show it very, very quickly. You didn't even see it. You didn't even see
Teaser.
it. And also, I've run into a problem in CAD that I need your guys' help on, because it's been bugging me for about 2 weeks. So stick around for a little bit, and we'll be going over all the reasons of why I suck at CAD, and I need the help of everyone else. But let's go ahead and show off everything in our community, what they have made. Oh, excuse me. This is going to take a second. Yeah, I'll show the window. There we go. All right.
You are sharing your entire screen.
Oh, fantastic.
Yeah.
Sorry, I'm on a new browser. Josh, you may need to do this.
Oh, interesting. Yeah. Okay. Let's see if I can do it. I'm going to share.
Very annoyingly, so we used to stream on Chrome, and every single time we do this, it would just add a bunch of filters, and it looks terrible.
Oh, it's my desktop now. That's cool.
Oh, awesome. Well, bring up some Discord. I want to see some cool
stuff. There we go. Little technical difficulties. Yeah, so we've got some I Made It things. I think we talked about the Arbor Press. I recall talking about this Arbor Press a while back.
Favorite tools that I own. I love Arbor Presses. If you don't have one, I cannot recommend picking one up. They're like $60. They make life so nice.
You can't reckon. That's the first time I think I've ever heard anybody utter the word.
Yeah, I know, because
if you don't have an Arbor Press, what you really need to do right now, stop what you're doing. Just go buy one. Just go buy one. If there's nothing more important.
Run, don't walk. Go and get an Arbor. No. It's one of those tools that will literally last my entire lifetime. You can fix it with like a screwdriver and like an old-fashioned oil can. And oh my, it just makes life so nice. Anytime I'm working on a project that I'm like, okay, I've got some gears, I got some bearings, I need to get them in place. It's like, oh, do I really need to tweak and get the super duper tight tolerance? It's like, nah, Arbor Press. I'm just gonna put 5 tons of pressure into this. Don't worry, the plastic will move out of the way. It makes life so nice. Anyway,
well, okay.
Continue on.
For all those of you who are going to not pay for a cell phone upgrade and instead are going to get an Arbor Press, we've got some stuff to show off. So, ZDP coming in. He's in the chat. Nice. Dan. He says, this is a sewing machine. Let's see. What are we looking at here? Sewing machine LED light converts 4 LED modules into a ring light to illuminate the sewing machine.
That's pretty sweet.
That is super cool. And then it looks like that is the product in action. So
that's actually really rad.
That's super cool. And dude, I remember how bad the lighting was at our previous shop. You couldn't see anything.
My God. We used to have, for some reason, one of those like gooseneck LED, hey, we'll get lights exactly where you need to on the sewing machine, and everyone would just keep on stealing it. Oh, I need it on the drill press in the metal shop. Oh, and I need it in the welding area. Oh, I need it in this. I'm like,
No.
guys, we only have so many outlets.
We have a Shishiko embroidered washcloth using CAD. Look at this,
That's
man.
awesome. That is
That
so
is
rad.
super cool.
I'm not sure I know what Shishiko is. Is it a pattern?
Well, it's got
or
Shishiko parentheses embroidered. I think it is Japanese embroidery would be my guess.
Gotcha.
But we'll have to wait for Mr. Dan. And then we have this awesome product, which I think you responded to this one. This is a laser cut. This person is into herbalism. And you can make these little test tube rack holders. Fun fact, I used to work in a lab, as many of you know. And buying these test tube / little holders used to be like ridiculously expensive. Like $100+ for one of these things that you can make in 2 minutes on a laser cutter and have it ready to go. So
it was I have also rented that. So my fiance also used to work in a COVID lab when she was like facilitating tests and all the science side of it. And I kind of walk in, hang out with them, and they were like, "Oh yeah, we have all of our racks, and they're all 3D printed." Like, "Oh, could you do this?" And at the time, I only had a small one. They were working on much larger things. I'm like, I'm really sorry, I can't do this. But I was looking at and I'm like, this is not amazing quality. This was probably printed up in like a couple hours. And like tack welded together with like a 3D printing pen. They look terrible. And they were buying them for I straight up I think like $100. It was insane. It was
So ridiculous. I mean, these are the sorts of things like you don't think that much about. I have a brief tangent about innovation. When you think about innovation, I think the thing that usually people are thinking about is the actual innovation itself, not necessarily everything around it. So this person is working on herbalism. They need a spot to put things, and there's probably maybe they just had a bowl with random stuff in it, right? So this is like this may solve a problem related to the innovation that you're working on. Right? It may be a step, it may be part of that process, but there's all this stuff that you need around the thing that you're doing to actually support it. So these kinds of products, I think we talk about this a lot too. It's like they're almost underdone and under talked about because people are like, oh, it seems too easy. Or it's just this little thing that solves this little problem. It's like, that is the crux of it. Little things that solve little problems become like, if you solve enough of those problems, you end up solving big problems. So love it.
I'm going to go on my own tangent as well. Little tiny solutions, tiny things that you create for yourself or for people who ask you to make stuff that on the surface you go, that's so simple, that could never be a product, are oftentimes the things that like people just have like a little side gig. My fiance has this like little makeup. I don't even. It's one of the makeup crayons. Can you tell I know what I'm talking about? And it's like a massive tube. It's about the size of a Sharpie, but there's makeup throughout it, but it only comes out the top. And so if you need to sharpen it, it's like you've only got that much. There is no twisting or plunger mechanism to get all of the makeup out. It doesn't exist. I ripped this apart. All the plastic parts were glued together with industrial adhesive. It didn't come out. So I looked it up. I'm like, am I an idiot? Like, why can't you get the rest of it? And there was Reddit posts, multiple, and they go, oh, here's how you do it. You chuck the entire thing in the freezer, and then you buy one of those gigantic, like oversized pencil sharpeners, and you screw it so you're sharpening the makeup and carving away the plastic at the same time. Because you freeze it, that like the makeup's a solid thing, it just doesn't get smushed. I'm like, this is insane. This is ridiculous. So I literally got a pair of pliers, cracked off the bottom plastic thing, and I 3D printed effectively a tall cylinder that had a bit of a base. So it's like something that you can put your thumb on, popped it at the bottom, and it came out the top. And it worked. And it works perfectly. Because it's makeup, it's got a little bit of tack to it. It just held in place.
You know what that feels perfect for, Jake? I want to talk a little bit about this for a second too. That feels perfect for a TikTok video. Easily. This is like the new school TikTok, but you like those old school videos that were the ridiculously silly infomercial, where somebody's struggling with a problem, but they're doing it in the most over the top fashion possible, right?
Yeah.
If you scaled that down to say 30 seconds, and then you just showed the ridiculousness and then the simplicity with, I bet you could actually sell quite a few of these things.
I bet you could. The problem with this that we run into all the time is that because it's so simple, it's very easy to steal. So it's like you probably make a pretty nice amount of money in a very short amount of time, and then somebody else will, and then there'll be 100 on the market, and it's like, yeah, we've run into that. So it's like, yeah, you can go for it.
Yeah.
But I love all simple things. Let's keep on going.
Alrighty, continuing on. A printable dream catcher. Wow.
That is
Again, just like absolutely crushing the designs. More and more flower of life, sacred geometry, printable. Again, a 3D printable object.
I really like these.
I think I remember ZDP. I think I remember you saying that you are more into the design side of things, but I'm seeing more and more 3D printed stuff. So interesting.
I agree.
I'm liking seeing it. Lock and a lid. Again, another simple mechanism here. Lid maintains an airtight, but permits filament to pass through. Oh, that's cool.
That looks very similar to my shining themed coaster that I have.
Nice. And he is just prolific.
Dude.
Wow.
Do you know about this Knights tour? Do you know what this is?
No.
This is
yes, I do. Yes.
Okay. For everyone who doesn't know, if you have an 8x8 chessboard, you've got the knight, or as people call it the horse. And I'm like, no, hate you. So it can only go up to and over 1. And there is a path called the Knights Tour where you can effectively start in anywhere, I think, and you can go around and hit every single square at least once. You're not allowed to overlap. And for a long time, mathematicians thought there was only one way to do it. And then computers come along, and turns out there's more ways to do this, I think, than there are like particles in the universe. It's like an absurdly high number where you can like do them in any different order you want.
That's crazy.
That's great. God,
that is crazy. I'm a huge chess fan. There's actually the computers have gotten so good at chess that the grandmasters can't beat the chess engine without a knight. It starts without a major piece, and the chess masters basically can't beat them anymore. It's ridiculous how good they've gotten. Also, they do this thing where you'll be like 100, they'll do 150, 200 moves, no problem. Where if you're a human being, you're like, there's no way I'm playing a 200 move game of chess.
Yeah.
I'm going to be here for a week, right? But the engine doesn't care. The engine is like, I'm setting something up for way out in the future. So fascinating. Love that. And especially because it's stuff like this too that turns like what is complex math into something interesting and approachable. And Jake, you and I are all about interesting and approachable when it comes to topics like math or CAD, for example. So I love this stuff. The balloon dog, again,
dude,
a classic.
I only saw it this morning. I love this so much. This is so flipping rad.
It's a really cool print. It turned out.
Yeah.
Very, very clean. Look at those layers. I mean, looks really
I'm going to
nice.
say something it's not a Jake rant, but it's pretty close. Okay. If you want to get it onto just the 2 shot of us, because I want this to be a genuine debate. Okay.
Here we go.
Here's my hot take. It's Jakey hot take. Okay.
All right.
Thick layers are better than thin layers. I think thicker layers, obviously they print faster, obviously, but I think they look better than smaller layers. And my argument is that it showcases the technology and it's not trying to hide or disguise what it actually is. If you wanted to have a 3D printed object that was it was completely crystal clean, perfect in every single way, you aren't going to achieve that by going smaller and smaller and smaller layers. You're going to do that by like hitting it with some primer and sanding and going through that whole process, or potentially doing it out of an SLA print. If you're doing an FDM print, I think they look better. I'm going to be prefacing this a little bit of context. Early 3D printers, I'm talking Ender 3 series, the faster layers, it literally made for a more wobbly print because there was more of a distance between the layers. And so you wouldn't have a nice clean line. It would kind of be, ooh. as the filament was coming out, so it looked terrible. So the thinner layers genuinely did look better. But now that we've got more solid layers or more solid printers that can hold up to that, and the filament isn't doing that, it's doing a laser straight line, the fat, chunky, thick layers, they look perfect. They look absolutely perfect. And I think aesthetically they look better and they print faster. Rebuttal.
I'm not sure I have a rebuttal, honestly. I think it makes me think of wood. So I hate painted wood for the most part,
Yes.
right? Like, don't paint your wood white. I want to see the wood grain. There's
Yes.
character in that. And so
Mhm.
I do think in general, I'm a fan of showing off the technology that you're using rather than trying to hide it. So I would agree with that. And it doesn't need to look like an injection molded part. It should function. It should, but it doesn't. I don't need to hold this in my hand and feel like it's a perfectly polished, ready to. So unfortunately, I wish I could debate you on this one, but I think I agree. It's to show off the technology. I think I would even go further. That's where there's when you show off the joinery, again in a woodworking project, like why not? There's this. Some people hide all of the hardware. They hide all of the features, but the opposite end of that spectrum is just highlight it, show it off. Make it bright, make it brass, make it pop, right? And I like that style, that contrast. So I wish this were a healthy debate. This doesn't feel very debatable to me. And
printed by John saying, me painting my new laser engraving product white. Laser engraving is a totally different argument, and I actually do agree to that. I agree you can paint that. It's like painting MDF. That's fine. That's totally fine. It's actually way better than using like sheets of acrylic.
Yeah, MDF doesn't count as wood. And if you're using a ply of some sort, that's like kind of wood, but like whatever. I'm not so if it's just a solid piece of wood.
I'm gonna drop some knowledge on you. Okay. MDF and plywood and OSB you put on like walls is technically a composite plastic on the same level as carbon fiber. The only definition of composite fiber materials like fiberglass boats, carbon fiber F1 cars is a fibrous material being held together by a plastic resin. That's it. So a fibrous wood layer that's glued to another one, as in plywood, with a resin glue in the middle, is absolutely in the exact same material umbrella as carbon fiber. Same thing for MDF. The particles are just microscopic. It's just powderized wood that's kind of in a slurry of resin glue plastic. That's carbon fiber. That's carbon fiber. It's just not black carbon, it's tree carbon,
I mean, that's funny, right? Like it is fibers, literally fibers of carbon glued together. It's kind of like bamboo. I wanted to build a bamboo bicycle for a long time because bamboo actually legitimately has some properties that compete with carbon fiber.
Oh yeah.
For example, in both strength and in dampening the vibration of the road. So when you ride these carbon fiber bikes, one of the things that people really like about them is that they vacuum up some of that vibration, so it feels smoother when you're riding it.
Rad.
And bamboo does the same thing.
That's awesome. I didn't know that.
Yeah. So and this was before I knew how to weld. I was like, how would I possibly build a bike? And they would actually wrap the bicycle frames in these strands of. It's interesting. I think they might have done it in carbon fiber. So they would take the bamboo and they would put the two joints together and then wrap it in carbon fiber with a resin. So it was like a carbon fiber bicycle.
That's so cool. I love that.
I love it. By the way, I hate MDF. I hate it. I just hate it.
Yeah.
It serves its purpose. There are reasons to use it occasionally. I just hate that stuff.
Yeah. It's naturally got formaldehyde in it, so there's a bunch of like health concerns with it. Yeah, and it weighs 1,000. Anyway, I want to go back and show off some more projects.
So we
tangent on a tangent.
The photographer showed his plastic clip that works with the developing tanks and prevent non-standard spools from sliding up and down the pillar. So I redrew it in Tinkercad and it works great. So
I'm not sure I understand what that is.
Let's see here. So I redrew it, developing tanks and prevents non-standard spools from sliding up and down the pillar. So it looks like just a little locking
workout
mechanism.
clip. Yeah, it's like what they have for for plate weights. Yep. That's rad. Okay, that's sweet. I dig it.
Cool.
All right. What else?
And printed by
Oh,
John. Look at
yes,
that.
I definitely wanted to click on this. So I found a bigger filed of a little Steadicam for filming. That's rad. This is sweet. I really dig this. For anyone who doesn't know, if you're ever filming something with your phone, because your hands are so close to your sensor, all these kind of wobbles go in there, and phone manufacturers and YouTube especially do a huge amount of work on algorithms to make this look smooth. But there's kind of a easy analog way to do this, and it's straight up just to put your hands further away from it. It's kind of like a capacitor almost, where it's smoothing out all the vibrations a little bit. So I've made a handful of these, and these are pretty sweet. These are pretty sweet. I dig that.
Hey, those are cool. Whoa.
I dig that.
These are the
That's
layered
really
prints,
sweet.
but they're 3D printed instead of laser cut.
That's awesome.
That is, I think those are, yeah, that's cool. Those turned out great.
I'm incredibly quickly going to try and find a product that I made for my fiance who's from Colorado. This layered laser cut. Oh, I don't know if I took a picture.
Okay, those are wood. Divine John says those are wood. Wow.
That's awesome.
I thought maybe you just did it with a 3D printer instead, which, by the way, you could totally do.
Yeah, of course you can.
Yep, definitely doable.
I totally don't have it. No. But yeah, making laser cut layered state flags. I think the Colorado one is really amazing. Just looks absolutely fantastic.
And then we've got a CAD design for a napkin holder, a chess.
That's pretty sweet.
Chess piece napkin holder. That is, I'm sensing some inspiration chess wise. Yeah, exactly.
Very chessy.
And that, I believe, is the end of the I Made a Thing.
Take it. Well, guys, that was absolutely fantastic.
That's awesome.
I love all of those. Okay, one project that we actually aren't able to share because it's something that was sent to us, not with a picture, I believe, but it was I think he was a research student. I'm talking. This is totally secondhand information. This was an incredible product that was showcased to us or sent to Josh that I actually want him to tell you guys about. But it was a new student coming into the CADclass ecosystem, and they said, "Oh yeah, for one of my design projects, I had to design a drone that could carry a man. It was powerful enough to effectively act as like a jetpack almost." And I'm like, that is so fantastic. So Josh, do you want to fill in the gaps a little bit?
I don't have any gaps. So somebody on Reddit said they went through our entire book and that they developed a drone that carries a person. There's a name for it. eVTOL, I think. Electric vehicle, eVTOL, I think is what it is.
I don't even know.
And apparently, by the way, there's been some regulatory changes around this concept, which is maybe allowing people to innovate in a way that they hadn't before. So this seems to be well timed on his part, but he used it to apply to get into MIT. So this was part of his MIT maker portfolio. Now, what I don't know is if the application was successful. And I also haven't yet seen a photo of it, but I asked on Reddit, I said, hey, if you've got the design of this thing, we absolutely have to see it. And he said he was able to carry basically a mock human being for 5 minutes.
That's
something like this.
That's an insane amount of time.
Yeah.
To do that.
And he was basically like, thanks for the book, best book ever. And I'm sensing that he must have really just like plowed through the entire book and said, okay, now I have the knowledge and skills to design this thing that I want to design. So if I wish I had a picture of it, I would show it off for sure. So
if any of you guys see that comment on Reddit, please reach out or try and message them like, hey, respond. They really want to see it. Okay. While Josh is
I don't see it yet, unfortunately.
That's all right, man. Okay. In the meantime, we want to let you guys in on one of the projects or one of the books and courses that we are publishing and producing right now. That it is coming soon, quite literally around the corner. Fingers crossed in like a couple weeks or less, potentially 1 week. Who knows? But we are finally, after I think literally years of people asking for it. We are finally coming out with our Onshape book. This is going to be our Onshape fundamentals in a similar breadth to our Fusion fundamentals, but as you can see, vastly more information, vastly more projects, challenges, we just kind of maxed out. This is, in our humble opinion, if you want to creep away from Fusion ecosystem and try out a different CAD software, genuinely, this is one of the best ways to get started on this. Obviously, we're biased, but this is taking literally years and years and years of maker and education and teaching experience and kind of smashing it into a book and teaching Onshape. So for everyone who doesn't know, I'll kind of start higher level. SolidWorks is one of the largest CAD companies in the world. They make incredibly powerful, but also incredibly expensive software that's used in, architects, civil engineers, mechanical engineers, automotive, aerospace. If you are a mechanical engineer or any type of engineer and you're going into a firm, it is very, very likely that you're going to be working on SolidWorks, because that's also what they teach in universities. That was the first class that I ever taught, or that I ever took, that was in SolidWorks. Incredibly powerful, but I think for one license for 1 year was like $10,000. So it's totally inaccessible to hobbyists and makers, and to be honest, us even, like 10 grand for years. Insane. It's absolutely insane. And so the head design chief, I believe that's his position, of SolidWorks, left with a couple more of the head engineers and started their own company called Onshape. It is effectively SolidWorks, the same logic, iconography, terminology, all that stuff, but on a browser-based software. So instead of having to work on a really large program like Fusion, Inventor, FreeCAD, anything like that, it is all done in your browser, just like Tinkercad. Because of that, efficiency is absolutely paramount on their list. It is the most important thing. So it runs incredibly quickly on a browser. So you can run it on your phone as well. You can run it on your tablet. You can run it on any device, as far as I know. Incredibly powerful stuff. And it's got a totally comparable base to it as Fusion. So we get a ton of people going, hey, love the Fusion concept. I love how you guys teach, but I want to learn Onshape effectively. And so finally, after a long time, we are finally releasing this book. We're currently going through the prototype phase. So I'm still doing a little bit. So I'll show you. There you go. That's all you get.
Oh, wow. Wow.
Yeah, blink and you miss it. But this is going to be the one of our definitive beginner books. So if you're just wanting to get into it, this is the way that we're going to be going. This is the instructor version. We're going to be making a similar student version. It's going to be released at the same time.
So Dan says, where is Onshape better? Better is a tough question, but specifically, it's easier to sign in. You do not need a heavy software that you download on a computer, which means that it works on basically any machine, right? So any computer that actually has access to a web browser, it should work just fine. The shareability is a little bit better. It's easier to share files. It's easier to find them in the public library. If you're a teacher or an educator, you can actually take control of your students' screens. So if they ask a question and they share the file with you, you can just take their screen over. So it's mainly around shareability. I know, Jake, you and I talked about this. We both actually do prefer Fusion from a design standpoint, but sometimes what happens is you go into classrooms and you have a harder time getting all of the software downloaded. This kind of solves that problem. And I would also say, if you're in the parametric CAD world, it's not so much that one is better than the other. They're just slight differences among them. And you sort of owe it to yourself to try other ones out just to see. And then it'll help you also understand the software that you're working on. So we are trying our best to be CAD agnostic. We want people to become designers and then to make amazing products. And so whatever it takes to support them. If you're part of a robotics team in high school, the chances are pretty high that you're using Onshape already. If you are of, say, the 20, 30, 40-year-old range, the chances are pretty high that you're using Fusion. And if you're above that, the chances are high that you're using SolidWorks.
That's a good one, yeah.
Yeah, right. So, but there's overlap between all of these, and so there is no reason to only use one. Test out multiple software, see what you like for yourself.
A big thing that
there's a big question here. Big drawback that keeps me from even considering it is all the files are public unless you have a paid license. That is absolutely the case, Steve. Yes, that is the case. So anything that you do is going to be publicly shared. Not that anybody can actually find it. But yes, if you're working on something that you feel is
millions of files.
If you're working on something that you feel is highly confidential, you're trying to keep your IP closed down, then yeah, that would be something you'd want to consider there for sure.
But one big thing that we do want to touch on, that's a big distinction in my mind, and it's something that we talk about a couple of times in the book, is effectively how do you think about the software? If you are positioning what's the difference between Onshape and Fusion, the best difference that we can find is that it is like relating Google Docs and Microsoft Word. One is a program on your computer, everything is absolutely local, and sharing the files is a little cumbersome. There's a couple extra steps that go into it, and if you're working on a big project that lots and lots of people are working on at the same time, it is impractically difficult. There's kind of inherent roadblocks that just makes life a little bit less fun. But in the flip space, because Onshape is all online, collaboration is absolutely the heart of it. So we've helped quite a few robotics teams where you've got potentially 10 people working on one project at the same time. There's people working on the architecture, people working on hardware, different components at the same time, different sub-assemblies at the same time, and being able to have multiple people interact, leave comments, leave screenshots, leave notes. Hey, I'm doing this, I'm working on that. You can manage people, seems to be the biggest hallmark difference. And it's something that it's a little bit alien to our normal workflow in Fusion, but it seems to be the biggest selling point, especially for person-to-person. But at the same time, it's just different. One big note that we kind of find coming across when both Josh and I are learning all these different softwares is that CAD is not program specific. We're fairly agnostic. There's absolutely some tools that are going to be the same across all of them, like, well, almost all of the design tools that are absolutely identical. They all use the same names. Like extruding or revolving or lofting or sweeping is exactly the same across all CAD softwares. It's just what does the icon look like and what's the color of the logo. That's basically the difference. When it comes to all of the extra stuff, hey, Fusion has rendering, it's got the animation workspace, it's got this and that. Oh, that makes it special in this way. So some people go, hey, that's something that I want. But if you are learning CAD, the actual logic that goes into it, you can apply it to any CAD software on the planet. It's just how you interact with that program itself. So if you know Fusion really, really well, which I imagine most of you guys do, going into Onshape is going to be significantly easier because you know the logic. You're not starting from scratch. It's kind of like if you speak English and then I'm going to learn Italian. And then you go, awesome, I'm now fluent in this. Now I'm going to learn Spanish. Learning Spanish is now categorically easier. Oh, I want to learn a little bit of this, a little bit of that. It's like, well, they all have shared logic paths, and all of them are very similar to each other in how they actually work. So sliding into all of them is incredibly easy. Yeah, as Sue said, the biggest thing is IP. This is a big thing that a lot of people said was a problem with Fusion as well, because it's a cloud-based program. All of your files are actually shared or actually stored on Fusion's servers. And so a lot of professional companies and firms, they go, no, we don't use Fusion because it's an IP problem. Side note, you can save all of your files to your own server on Fusion. It's not a security problem whatsoever. But that's why a lot of people choose SolidWorks, is because absolutely everything is on your local drive. So that's a big thing.
Which would be true of Inventor as well.
Yeah, absolutely. Yeah.
Yeah, kind of the SolidWorks competitor there.
So that's a very large project coming down the line in a couple weeks. Very excited. If you guys are interested in that, reach out to us. And as always, all of our books we will have available for free as a PDF on our website. So if you want to go and check it out, download for free or for a absolutely no pressure donation, more than welcome to. The other book that we have coming down the line, I think we need to title this episode "Good God, Finally," is we are now working on a surface modeling and surface designing book coming out. No idea. Coming out in no idea. This has been a big bit or a big topic that we haven't really done a lot of work into in the past, and now we've got way too many people asking for it, and it's like, okay, we finally need to do it. Finally need to show it. For everyone who doesn't know, anytime you're in the design workspace on Fusion or really any CAD software, I can't believe we have to say that now. Anytime you're doing any solid modeling, you're effectively working with very rigid dimensions, precisions, tolerances, etc. You're making all these parts. But if you are making something that needs to be ergonomic or organic in shape, for example, a computer mouse is a really, really good example of this, where it needs to be very curvaceous and organic in lots of different ways. Then you kind of need to leave the solid modeling workspace and go into surface modeling or forms. This is where it's a little bit more akin to sculpting with clay, where you're literally pulling and pushing and moving and merging different facets. And it's a different topic because it's quite literally a different mindset. It's one of those bits of CAD where it's like you kind of need to forget everything that you know because how you would approach this is now completely different. But this is a big topic. It's a big part of CAD that we've never really touched on, and we're finally going to get kind of our feet stuck into it. So, if anybody in our audience has any projects or any topics in mind that they would go, oh, finally, I really need to learn this. I'm working on this project, anything like that. Please let us know, and we will try and work it into this book and into our course as well as possible. The other bit of this is that we're potentially going to be exploring 3D scanning into that as well. We get a lot of requests from people saying, hey, do you do any 3D scanning? It's like, not really, not really. And the big bit of 3D scanning is that as soon as you have a mapping of an object, regardless of if it's organic or kind of faceted and dimension, you are going to be having gaps in that file. There's going to be things that need to be repaired in the mesh. And this is something that you can do inside of Fusion as well. And the bridging between surface modeling and mesh work, there's a little bit of overlap. There's a little bit of gray area in between. So we're going to be trying to cover all these topics inside our new surface modeling book. But again, if you guys have any projects or any logic workflows you'd like us to go over, we'll absolutely try and fit that into the book. All right.
Yes. Great. Yeah. Excellent. Yeah. So those are like the most common things that we get asked is about importing those 3D scanned files. We really should talk about that. So we are listening, by the way. So so I think I would say I would also encourage you all to continue asking us to do things that you hope that we get to, because the more people that ask about those things, the more likely it is that we spend a little bit of time trying to do them. So
on a side note, before we leave this, I just saw PC Van Vliet saying Printables is running a mouse design contest at the moment. Mice and I think tool handles are a big thing on my list because I just love designing that, because there's so many kits nowadays that it just has, the buttons, the sensor, and the motherboard and the frame, seriously, and you could just design anything around it. Total side note, I cannot recommend people getting a vertical mouse enough. I've been using this for like a year because I was getting a little bit of like carpal tunnel going on, and I'm like, I can't work anymore. Getting a vertical mouse is ridiculously good. I've been using this Logi, I think it's called the Lift mouse. I've been using it for like a year. This took about maybe 2 days to reprogram my mind, where I'm like, okay, I'm now moving this way instead of that way, which is now totally weird. I cannot recommend it enough. I love this mice so much. I'm like, I've still got all of my flat mice in my desk, and I'm like, who needs them? I do. So I'm going to be keeping this forever. But a vertical mouse, I cannot recommend it enough. I love it. I love it so much. I still have yet to try a CAD space mouse as well.
I actually have one.
Oh,
it's just sitting there, and I'm like, no. Every time I think I'm going to maybe use it, I'm like, nope, don't need it. Not going to use it.
Do you know which type it is?
Well,
do you have it on hand? Because there's a bunch of different types. For everyone who doesn't know, a space mouse is, from what professional CAD engineers say, is the kind of holy grail tool. It's effectively a tool. It's a mouse that allows you to zoom, pan, and orbit all in one maneuver. So instead of having to, shuffle around the keyboard and your mouse, you're able to do it in one smooth, sweeping fashion. Lots of CAD people swear by it. I've also seen slightly less than equal amounts of people going, nah, it's waste of money, it's a waste of time. Nah.
I'm not seeing it. I'm not seeing it next to mine. It's somewhere here, but I'll have to dig through stuff.
I'm totally.
I think it starts with an N, like next. Let's see there.
Maybe. That sounds about right, dude. But if you find it, if you're not using it, send it down to me, and I totally want to figure it.
3D connection.
3D, yeah.
Connexion. However you say that. Yeah. That's the one. Yeah.
I want to try one.
I'm not using it. I can send it to you. And I just don't. I'm not building complex assemblies. I'm not. Yeah, we'll see.
Well, that's a really good transition, because speaking about complex connections and complex assemblies, I have been stuck on a project for weeks now, and I'm kind of running up to this wall. Not a timeline, but I'm running up to a Jake's sanity wall, where I'm like, I straight up don't know what to do. I don't know how to fix this. So, as some of you guys know, I have been in the process of recreating a 1-to-1 100% metal R2D2 ever since COVID. That's when I was like, okay, I can do huge amount of like research and CAD work. And since we have a new partnership coming up with Send Cut Send, I'm now being able to have all of these, all the sheet metal parts at least, manufactured. So super unbelievably duper excited about making that. We're going to be coming out with some videos about that over the years. A lot of people who are in the R2D2 builders community, they say on average it takes about 5 to 25 years to build an R2D2. I think 2 or 3 years into it so far of like doing all the CAD, and I'm finally getting around to it. So I'm a little bit ahead of the curve, a little bit. But this is going to take years on end. And one of the bits of this is that making all the components have now forced me to learn much more about CAD and use different tools that I didn't know I'd have to use. So I had to redesign huge parts of R2D2 to turn him into sheet metal, which is another aspect of CAD, very, very similar to the surface forming tool, where it's different tools specifically for that technology. So I've had to recreate huge amounts of this project, but it's been fun. It's been totally fun. But there's one aspect of this project that is kicking my ass, and I literally can't figure it out. To the point where I will literally be in the shower taking notes on how I can solve this and scribbles and this and that, and I still can't figure it out. Okay, let me grab my R2. So this is my buddy. Okay. Everything about this design is, or almost all of it, is sheet metal. There's a couple CNC parts on here, on this beautiful, beautiful design. But on the feet of R2D2, if I can get him in frame, this shape, the entire white mass, is a 4-sided pyramid, effectively. But these angles, the left and right, and the front and back, are in completely different angles to each other. It's not like, oh, it's 20 degrees or 10 degrees in going this way and front to back. They are totally different to each other. And then underneath them, they have conical underbites as well, which is a fun word to say. Making, or actually designing this in the sheet metal CAD workspace has been nothing short of a nightmare. It's been nothing short of a nightmare. If anybody can figure it out in our Discord and post it on the I made a thing or whatever, and just tag me on it. Effectively, all you need to do is start out with a flat plane on the top and come down at diagonal angles and make 4 sides. That's all I'm looking for, where the front and the back are, let's say, 10 degrees, and the left and right on the long sides are at 5 degrees. And the seams where they run need to be nice and neat. There are tools inside of Fusion that allow you to do flanges that come all the way down, and then you can adjust the angle, and that and the actual edges where they meet will diagonalize so that there's a nice neat seam down the middle and everything works out. That's not what I'm talking about. That only works if all 4 walls are splaying out at the same angle. In mine, The side walls and the front and back are completely different angles. This has taken me most of my sanity, because I'm effectively designing around three separate global coordinate systems and trying to extrude, cut, and extrude out. But then because it needs to be unfolded, everything still needs to be in a 2D top-down perspective. It's maddening. It's absolutely maddening. Basically, once a day, I'll be in the shower. I'm like, oh my god, I figured it out. Sketch. And then I try and do it, and I'm like, it doesn't work. I can't do it. So this is not so much a challenge. This is a call out of despair. I need someone's help to figure this out. And I guarantee someone will do that in our community, and they'll go, "Oh, it's dead simple. Just do this."
So this feels like it needs. I need help making a thing.
Yes.
That's what it feels like. It belongs in the Discord. So
yeah.
Jake, why don't you put up some of the dimensions or what you just asked for with photos that are relevant?
Annoyingly, I can't share my screen.
No, you can't. So we'll have to go back to Chrome, your favorite.
I hate this.
We had some artifacts. I mean, that's a side note, but we've had some weird issues with Chrome, specifically with your camera, where it adds shadows, and we just can't figure out why.
There we go.
Hey, look at that. You can do it. It works.
Okay. Can you see my screen?
I can see it.
Okay, there we go. All right. Sorry. Okay. So I've shown this before. There are, I think, about 2,500 pieces that go into R2-D2. It's a huge amount. And so it literally needs to be organized and categorized and folderized so deeply. Every single one of these pieces is like unbelievably, cataloged and named, and everything is saved, and it's lovely. And this is all high level organization. The foot of R2-D2 needs to be a whole separate thing. So inside here, I'll just go ahead and hide some pieces. Effectively, there's an ankle up here. That's just a ghost part. Don't worry about this. There is the actual chassis. So this is the structure of R2-D2's legs. There's going to be a chain linkage. This is just a normal 150 watt motor. This is what you find on like electric wheelchairs. So it's plenty good enough. R2 is going to be about 200 or 300 pounds of weight as soon as he's done. So he'll be okay. But basically, this is the chassis inside it, and then I am building effectively the shell that goes around him. That's why you have to build it in place. There's a little bit of tolerance here, so you can see there's some gaps going on. But basically, let me go ahead and hide the foot shell. There is a track that runs down the middle of this foot shell. If I go ahead and not let me expand this. There we go. There's an inner track that runs down the middle of this. It's pretty simple. It's just a flat section with some angles, and they get folded in. Not too bad. Then there is this part. If I just isolate it, this timeline used to be a couple seconds of scrolling distance. So as you can see, I'm just working with a couple faces right now. This front section, this large wall, is at a completely different angle to the front and back sections. Or excuse me, this side, these outer ones, they splay out much further than this angled wall right here. Having a really nice seam between all of them is absolutely driving me mad. Like, you literally need to design it with like interference parts and then try and cut them away. And it's nothing short of a nightmare. And it's even more annoying because it seems easy as can be. And it couldn't be further away from it. Anytime you're designing sheet metal parts, they physically need to have a small separation, a small gap in between it. So you'll see on like corners, there's a certain area that's missing. That's totally fine. I'm going to be going back and TIG welding all of this, all these aluminum parts. That's not a problem. I want to have built-in gaps. I want them to be as tight as possible, but that's fine. But straight up, like enclosing all of these it's absolutely maddening. I know this doesn't look that complicated. It's because I've stripped out so many details to try and simplify it. And even then, I can't figure it out. So yeah, this is an unashamed call of help to the community. Please help me. Dear God, please help, basically.
Unashamed.
I'm totally unashamed. Totally unashamed. This is
I'm
like,
unashamed about nothing.
I am a little bit ashamed about this. I mean, it's us. I should know how to do this, and I can't. And it's and so I'm needing some help from our crew. So yeah, please help me. It just sounds like a plea of help. Please help. Please send money.
Yeah. Do we cue the Celine Dion music?
I was gonna say for only $1 a day, you can help Jake regain some sanity, for God's sake.
Yeah.
So I'll be posting this file. I'll be posting some of the dimensions. But yeah, this is a bit that I seriously need some help on. But yeah. To finish off this pod, I want to talk about something completely different, and it's something that I'm sure lots of people are seeing ads for. But it's a bit of a discussion. So Josh doesn't know anything about what I'm going to say, and I actually want a ton of his input on this because it's a very, very, very different topic. So there is a new electric car company that's coming on the scene called Slate Auto. It's this small engineering company that got huge funding from Jeff Bezos, from Amazon, and they are now about to release this new truck, effectively. The engineer who runs it, she's been in the automotive engineering scene forever, and she's effectively said the mission statement is to make an electric car that is simple. It's not for techie people. It's a simple car / truck that you can customize in every single different way. It's really expensive. I think it's about, sorry, really inexpensive. It's about 20 grand for a base model. And the whole point of their website is you can go on there and you can effectively customize the color, the shape, the style, the seats, the accents. I want this banner. I want this, and this. And it is a dead simple thing. And the customization is the biggest bit about this. And I can't remember what type of car. Josh knows, but there is I think it's a Ford car that came on the scene a couple of years ago, and every single aspect of it was a publicly available STL. So if you wanted, you could custom design part of your car, 3D print it, and it just fits in place. Do you remember which one that was?
Ford Maverick.
Ford Maverick, yeah.
Yeah, I still kind of want that. That's like still what I would like.
Yeah.
Right? This idea of hybrid, but yeah, keep going.
And so this idea of having complete customization of a car or truck, I think this has only really come down in recent years. I think from the 3D printing community, and I could be completely wrong, or at least from the maker community, where people are now saying, I can buy a product and that's just fine, but now I'm able to customize it and change it in, I think, obscene, like hundreds of thousands of different permutations. I'm able to do that because as consumers, we now have tools and abilities and technologies that we can kind of customize anything that we want. And files are now publicly available that people can customize it even if they have zero CAD experience. If they have zero 3D printing experience, they just happen to own one, they can now customize anything in any different color, any different filament, and really to a fundamental depth. And this is, I think, one of the first companies that I've seen that has this as their kind of front-facing marketing scheme, where they go, "Oh, we don't paint any of our cars; we just put wraps on them, so you can make them in any different color that you want, and we've got a whole spectrum of different colors that we can use. You can pop off the back, and you can just buy this top that fits on it, and it's now not a flatbed; it's now an SUV." And it just all clicks and pops into shape. And it's literally meant to be as simple as can be. I think the metaphor of going early 3D printers of just this mess of wires and software and firmware, it was totally inaccessible to people. And then simple, very easy to use, very technologically advanced, but pulling that difficulty and pain in the assness away from the customer, from the consumer, is so unbelievably powerful now. I want you, Mr. Joshua, to tell me what you think about this.
I lukewarm.
Really?
Yeah, I feel lukewarm. I think it's an attempt to do something that people love at least historically, people have loved their cars. They're car enthusiasts. They go, they
Mhm.
fix their cars up. This has been a common thing for a while. I I actually think for better or for worse, and maybe even for worse, that we're going to be moving away from a world of car ownership, mainly because self-driving technology is pretty expensive. So we're going
Yeah.
to be moving towards a sort of a rent your monthly vehicle kind of approach,
Yeah.
right? So the idea that you can customize something that you don't own is like part of the thought I have. I also think that in terms of customization from like if I were to think about going and buying a car, I actually just want the car to work like a car. I'm not
You just
all
want it
that.
dead simple, really.
Yeah. And when you said simple, what really perked my ears up was what I want are buttons and knobs.
Mhm.
I don't want
That
touch screens.
that is what this company's about. They say electric cars become too technologically advanced in a negative
Just
way,
give me
and so
buttons
they go. So
and
they
and like a
don't have
shifter
any
or
touchscreens. Yeah,
yeah.
that is
Yeah, that I
exactly what this card's
really
about.
that part I really like. The customizability, I'm not sure I'd want to go and spend all that much time like picking out all these features. And I'm also like I don't buy new cars. I buy used cars.
Yeah.
It's never made sense for me to buy a new car. It's probably I hope I can say this, but it maybe never will make sense for me to buy a new car. It's just I can buy it used.
Yeah.
It's fine, right?
Yeah.
So I could see somebody else customizing a little bit. Fun fact, back in the day, one of the first ways I got my start making stuff was actually modifying a Honda, or not a Honda, Dodge Neon.
All
I
right.
had a Dodge Neon, and I customized the interior, and I ripped the whole thing out. I put a system in it. It was like my first experience, like getting a hands on a car, and that was enough. I don't,
Yeah.
I, I'm not all that into. I'm like, I think I just made it worse. I now
I.
like have all these painted things, and so ah, yeah, I don't know. I'm
But
not
what do
all
you think
that
about this
jazzed about
concept
it.
of like ultimate customability across all
Don't love it.
products coming out?
I think we have too
Really?
many choices. I prefer fewer choices. Just give me the car that works
Really?
well. Yeah, just give me the car that works well. I don't like what do I need in a car? I need to get from A to B. I want ideally I'd like I'll tell you what I obsess about with cars and mechanical objects, let's say, is silence. I want the inside of the cabin to be silent. Period. Like I don't want to hear the whine of the electric motor. So if I were to customize anything, it would be around sound, right? I don't want to hear the whine of the motor. I don't want to hear the road noise from the tires. I want to feel like I'm in this like peaceful place.
And then there's
So
someone behind you honking their horn like, "Go, just go!" And you're just
yeah,
like, "Yeah, whatever,
yeah.
whatever."
Especially road noise, like tire noise. I guess you don't have to hear nothing, but hearing the like that same like on a bicycle, for example, when I can hear my bicycle chain making noise and I
Mhm.
need to put oil on
Drives
it,
you
I'm
insane.
like, I really should just switch over from a belt or from a chain to a belt because belts
Yeah.
are basically silent. And that's like the silent ride. Or if I hear something squeaking on my bike, it's the same deal. I'm like, I don't
Yeah.
want to hear that squeak.
Yeah.
That takes away from the joy that I have here. So yeah, I guess from a sound
Interesting.
standpoint, but from a customizability, what would I add on it? Like nothing actually.
Really?
What do
I'm
I
totally
need?
the opposite. I get so giddy at the idea of making this thing mine in every single different way
Yeah.
possible. So I'm totally giddy on this. I think if they can pull it off, amazing. Side note, it's all being manufactured in Long Beach, which is the city of my alma mater. So it was like a massive manufacturing hub of America, very similar to Detroit, but less specifically in cars. And this is now kind of trying to restoke some of that underbelly of creation, uh, which I'm so stoked about that. That's gonna be awesome.
Awesome. Well, this has been the CADclass Podcast. Once again, I'm Josh.
I'm Jake.
I will see you all next week. Cheers, everybody.
See you later, guys. Peace.